Hi there. Are you ready for today's glowing topic? Let's dive in. Ever wondered why some toys glow in the dark or how jellyfish light up under the sea? Let's explore what makes things glow and discover the science behind the shine. But first, let's just have a quick recap on what is light. As you already know, light is a type of energy that we can see. Now, usually this light is made from heat, like the sun, fire, or even a light bulb. But guess what? Some things glow without heat. Let's see how that works. Luminescence. This luminescence is when light is made without heat. There are different types of luminescence, so let's break them down. Phosphorescence. This one stores light and glows slowly. That's your glow in the dark toys or stickers. Next, chemiluminescence. This is made from chemical reactions like glow sticks. Next, bioluminescence. This happens in living things like fireflies and jellyfish. And lastly, fluorescence. This glows instantly under light, like a highlighter pen. Pretty cool, right? Each type glows for a different reason. Let's start with phosphorescence. Phosphorescent objects absorb light energy and release it slowly over time. That's why glow in the dark stickers or toys shine in the dark, but only after being exposed to light. They need to be charged first. So, how does phosphorescence work? Here's what happens. The toy absorbs light, like sunlight or UV light, and stores that energy. Later, it slowly releases it as a soft glow. Even in a dark room, it keeps glowing. Neat, right? Chemiluminescence. This glow comes from a chemical reaction, like in glow sticks. There's no battery, no heat, just science in action. Okay, now let's see how chemiluminescence works. Well, a glow stick typically looks like this. It has an outer plastic casing and inside there is a glass vial. Now, in normal conditions, the two liquids which are inside the entire glass vial are kept separate. How so? Because one liquid is in the plastic casing, that is hydrogen peroxide, and the other liquid, which is a fluorescent dye and a chemical, are inside this glass vial. Now, when the stick is bent, the glass vial which is inside breaks, and of course, the plastic casing remains intact because it's made of plastic and it is bendable. However, due to this glass vial breaking, the liquid inside and the liquid in the plastic casing now mix, and boom, it causes a chemical reaction which we see as the glow. Bioluminescence. Bioluminescence is glow made by living things. Fireflies use it to attract mates, some deep sea fish use it to hunt or scare predators away. Nature's glow is just full of purposes. Now, let's see how bioluminescence works. So, here's the science. Bioluminescent creatures have a substance called luciferin inside their body. Now, this luciferin reacts with oxygen inside the body, and this reaction is helped with an enzyme called luciferase. Now, this chemical reaction produces light, and that is what we see as glow in them. Now, let's have a look at fluorescence. Fluorescence is a quick glow. It happens only when the object is under light, like a black light or UV torch. As soon as the light is off, the glow disappears. Think of a highlighter ink or glowing posters at a party. All right. Now let's see how does fluorescence work. For this, we'll compare the normal non-fluorescent objects and fluorescent objects. So in normal non-fluorescent objects, they absorb the visible light and reflect some of the colors that we see, and most of the other light is just turned into heat. While in fluorescent object, what happens is they also absorb extra energy light like UV light, and instead of converting it into heat, it gives it off again as visible light. And that new light has a longer wavelength, so it looks extra bright and glowing to us. So, where do we use all this glowing tech in real life? Let's see. Phosphorescence is found in safety signs, emergency exits, and watch dials. Chemiluminescence is used in forensic tests, medical kits, and even fishing lures. Bioluminescence. It helps in marine research and exploring the deep sea. Fluorescence is used to check real money. It's used in ID cards and for making neon signs pop. So the glow isn't just fun, it's functional. Okay, here's a quick recap of what we learned. Light can be made without heat, and that is called luminescence. Phosphorescence glows slowly after absorbing light. Chemiluminescence glows from a chemical reaction. Bioluminescence, light made by living things. Fluorescence glows instantly under light, stops when light is off. All these kind of luminescences used in glow toys, safety gear, science tools, and even in nature. All right, now it's time for quiz. First question. Which glow needs to be charged under light first? Bioluminescence, phosphorescence, fluorescence. Think about which one glows slowly after light exposure. That's right. Phosphorescent objects absorb and store light before glowing in the dark. Next, what makes glow sticks shine? Battery power, heat, chemical reaction. Remember what happens when you bend a glow stick? Exactly. It's chemiluminescent glow made from mixing chemicals. Okay, next question. Which type of glow happens in living creatures like jellyfish? Bioluminescence, chemiluminescence, fluorescence. Think which one includes fireflies and deep sea fish? Yes, bioluminescence. Living things produce their own glow using natural chemicals. Last question. When does fluorescent light stop glowing? After the chemical finishes? When oxygen is gone? When the light source is turned off? Remember, fluorescence only glows under light. So, great job. Fluorescent glow ends the moment the light goes out. Well done, science sleuths. Now you know the glowing secrets behind toys, creatures, and even science tools. Remember, every glow has a reason. Keep asking questions, keep exploring, and stay curious.